Calculation 5 in Chapter 7, Heat Loss from a Buried Line. A steam line with a diameter of 12.75 inches is buried with its center 6 feet below the surface in soil having an average thermal conductivity of 0.3 BTU per hour per foot per degrees Fahrenheit. Calculate the heat loss if the pipe is 200 feet long, the steam is saturated at a temperature of 320 degrees Fahrenheit, and the surface of the soil is at a temperature of 40 degrees Fahrenheit. The heat loss is given by this equation, where S is the shape factor, K is the thermal conductivity of the soil, and T1 and T2 are the surface temperature of the pipe and the soil respectively. Also, the shape factor S is given by this equation, where L is the length which is given to us as 200 feet in this problem. Z is the distance from the ground surface to the center of the pipe, which is given to us as 6 feet, and D is diameter, which is given to us as 12.75 inches. The diameter D can be converted to feet as 12.75 divided by 12. This will give us D as 1.0625 feet. The quantity 2Z over D now can be calculated as 2 times 6 feet divided by 1.0625 feet, and this is equal to 11.294, and this quantity is dimensionless. Now, having the quantity 2Z over D, and also we know that inverse hyperbolic cosine of x is equal to log natural of x plus square root of x squared minus 1. Therefore, inverse hyperbolic cosine of 2Z over D, which we have in here, is equal to log natural of 11.294 plus square root of 11.294 square minus 1. This will be equal to 3.116. Now we can substitute in the equation for S and calculate it as 2 pi multiplied by 200 feet divided by 3.116, and this will give us a shape factor of 403.29 feet. Now we can calculate the heat loss Q equals to 403.29 feet for shape factor multiplied by thermal conductivity, which is given to us as 0.3 BTU per hour per foot per degrees Fahrenheit, multiplied by T1 minus T2, which will be 320 degrees Fahrenheit minus 40 degrees Fahrenheit. And we can simplify, and we will get Q in BTU per hour as 33,876, which is equivalent to 9,926 watts.